It's Wearable Wednesday again here at Adafruit, and today we're making a project you can take on the road. My friend Keith rides a motorcycle, and he told me he thinks that his brake lights and turn signals are too hard for other drivers to see and asked for my help. So I grabbed his backpack, and with the help of some weatherproof LED pixels and the Flora, today we're going to build this remote-controlled brake light backpack. It's also got turn signals.
Start by wiring up the battery pack inside the weatherproof enclosure. You'll tin the leads of the switch that you've inserted in a hole in the enclosure with a little bit of solder. Do the same to a 2-pin JST cable and use your switch to break the power lead. So solder one lead of the switch to the red line of your battery pack and the other lead of your switch to the red line of the JST connector. Then you'll solder the black ground lead from the JST connector to your battery pack. This way you'll power the Flora through the JST port and have a nice switch far away from the battery pack to control the bag from the outside.
Originally I thought that a 4 AA battery holder would be perfect for powering this project, but it turns out that even with rechargeable batteries, the voltage ended up being too high. So stick with a 3 AA battery holder or bridge one of the battery compartments as I did here.
We'll use this Flora accelerometer to detect when we're braking, so hook that up to your Flora and solder the connections with little pieces of wire. Use little pieces of Velcro tape to attach the Flora and accelerometer to the battery pack, which is also affixed the same way to the enclosure, and leave space for the wireless module that we'll attach next.
It's a good idea to prototype different building blocks of your project independently before trying to combine them. For instance, here I've got our little wireless module hooked up to some LEDs so I can see the output before I try to hook it up to my Flora.
This RF module operates at 5 volts, so we'll build a simple voltage divider with two 4.7K ohm resistors. Just put one of them from the output pin of the RF module to another pin in your breadboard and then another one to ground, and then measure the voltage at the junction of the two resistors. And we'll see we get a much more manageable 3 volts that will trigger the digital I/O on the Flora. So for every button you want to use on the remote, take two 4.7K ohm resistors and twist the leads together and solder them to the I/O pins on your Flora. One resistor from each pair will be soldered to ground, and the other one can be soldered to the output pin of your RF module. These female jumper wires can come in handy for connecting to the header pins on the RF module, and don't forget to use your heat shrink tubing. Also connect ground, and then power goes to VBAT on the Flora, which is the pin connected to the same voltage as is coming out of the battery pack. The hole you bore in the weatherproof control box will allow you to connect to your power switch and your pixels. The hole shouldn't be any larger than it needs to be. It just needs to let this 4-pin JST cable through as well as your power switch leads. Pass the cable through the hole in the enclosure and hook it up to a strand of your pixels. Then use small pieces of heat shrink tubing to mark the ends of the black wires to correspond with the order of the colored wires in the pixel strand. This way, when you're soldering it to your Flora, you'll be able to hook up the right wires to the right pins the first time. Solder power, ground, and the 2 signal wires from your pixel extender to the Flora. And there's a circuit diagram on the tutorial on the Adafruit Learning System if it's starting to look a little bit hairy. Next up, everything goes inside the enclosure, and you can put the RF module on your battery pack with another piece of Velcro tape. Plug in the Flora's power and set any switch on your battery pack to on. We'll be using the external toggle switch to power the circuit. And then use a zip tie for strain relief on any cables exiting the enclosure. Now that the control circuit is finished, it's time to plan out the LED design on the backpack. So I've traced this slimline motorcycle backpack onto a piece of poster board, and I'll just use some Taylor's chalk to sketch out where I want my LEDs to go. I can then use a ruler and a marker to transfer this pattern to the poster board template, which will help me wire my LEDs properly, plan out my animations, and generally save a lot of headache later when we want to go embed the pixels into the backpack. Set up your pixels in this cardboard jig of sorts, and you can follow the diagram in the tutorial for the way the pixels will snake around the double diamond shape. These pixels come in strands of 25, so if your design is bigger than that, you'll need to either plug the pixels together with the connectors provided or cut them off and solder the connections with a lot of heat shrink tubing for an extra weather-tight seal. And when you get to the end of your design, if you have extra pixels, you can just cut them off, but then make sure to fold over and heat shrink all the loose wire ends so they don't ever short out inside the bag. Give your pixel design some structure by adding zip ties and tape so that when you remove them from the template, they sort of hold position. This will make it a lot easier to get the positioning right inside the bag. But easier is relative because the install of the pixels is probably the most challenging part of this project, and there's no exact science to it. I would just hold the templated pixels up inside the bag, see where the pixel wanted to poke through, cut a hole for it, and since the backpack's nylon, you can actually heat seal the edge of the hole so you don't get any more fraying. And then I would stitch stitches around the wires connecting the pixels so that the pixel would stay flush with the surface of the bag. It can be hard to reproduce your design exactly, but if you end up with a couple pixels in the wrong spot, they're individually addressable so you can fix it in the code. I just love these clicky tactile on-off switches from Judco, but they're not waterproof, so I'm going to use some Sugru to fix that, because I want the switch to be on the outside of the bag. Just use a piece of plastic to shield the button so it doesn't get gooped up, and then use the Sugru to form around the switch all the way down to the leads. You can wear rubber gloves to prevent your fingerprints from making any imprints, and then leave it to dry for 24 hours. Also use some Sugru to waterproof the hole you made in your weatherproof enclosure, and then pop on the lid and put it inside the backpack. Extra long wires will help you put the switch close to the rider, but I'm still going to keep it in this front pouch so that belongings in the main part of the backpack won't snag on the wires. Just cut a small slit for the switch to poke through, then heat seal the nylon as before, and then stitch the switch in place, adding a zip tie to stitch to if you think it's necessary. Prop your bag up and start testing out the LED animations. Our open source code includes brake lights and turn signals, but you can modify the design to make your own flashing LED pixel animations. To get maximum range out of the RF receiver, uncoil the antenna and wrap the wire around the perimeter of the weatherproof enclosure. This should give you enough range to use the remote on the dashboard of your motorcycle, either Velcro taped right on, or you can break it apart and have one button on each side.
Just to be clear, this project is water resistant. I wouldn't take it scuba diving, but if you get stuck in the rain, I'm sure it'll be just fine.
Pack up your circuit one last time and let's take it on the road for a test drive.
So I'm pretty psyched with how this project turned out, but there's tons that you could do to make it better. So check out the code that's available on GitHub and the step-by-step tutorial on the Adafruit Learning System. And then share your project with us on our weekly show and tell on Google+. As always, thanks for watching, and don't forget to subscribe to our channel here on YouTube.